Yeah, so hi, and indeed, I'm Henrikki Tenkanen. I'm assistant professor at Aalto University, as Alessia said. And today, what I'm going to talk you, the monster title that I have in here is basically Spatial Data Science meets Sustainability, and that's kind of the one half, and the second half is the growing the next generation of scientists with open technologies and empathy. And basically, I have kind of two parts in this talk, and the first one relates to education. So I kind of want to share you a bit of the things what we have been developing at mostly at University of Helsinki actually, and then now at Aalto University with my new course that deals with sustainability science issues, and kind of the what our big question and goal has been is to question about like how to educate future scientists or experts that are skilled analytically, technologically, but also that would be able to actually use those skills to questions that matter. Of course, what are those questions that matter? It's up to you and up to many of us. But of course, the sustainability kind of topics are one of those things that are quite topical at the moment, thinking where we are with the world and today. And the second part is a bit of like not related to education, but a bit of science as well. So basically what I will talk you is a little bit of this kind of bibliometric analysis that I've been doing, trying to understand how the GIScience kind of community is engaging with the sustainability kind of science based on the kind of articles that we publish in different journals in our fields. So those two topics I will discuss. And thinking of sustainability and spatial data science, so as you probably can think yourself as well, those are huge topics on their own. And of course, what I will share is basically my view, how I see those things. And as a scientist, so maybe kind of useful to know a little bit of background about myself. So I have been doing, in terms of the research, quite a bit of research related to spatial accessibility modeling and human mobility analytics. The other kind of side that I have been doing quite a bit of work relates to human nature interactions, for example, using social media data to try to understand how people use, for example, protected areas or national parks in different parts of the world. And kind of my role in here has always been, of course, I'm a geographer by training, but geoinformatics has been my major. So kind of GI science and data science have been always close to my heart. And it is this kind of triangle that I have been doing quite a bit in my research. And kind of the underlying motive for doing this work always has been to support spatial planning. So the kind of practical side has always been quite strong in the research that I have been doing. And well, most of this work has been done with my colleagues from University of Helsinki. So of course, they have a big group at the Digital Geography Lab dealing with these things there. So that's kind of the scientific kind of angle that I have to these questions. And of course, thinking of these things, so they all relate quite a bit of quite a bit to sustainability from different perspectives. And then the other view that I have is as a teacher, and this is probably the work that I'm more known for. So what we have been doing with my colleagues David Whipp and Vuokko Heikinheimo, so we have been developing quite a bit of these open source educational materials. So basically two courses, GeoPython and automating GIS processes. And with those, the kind of idea has been to try to educate geographers without any background kind of experience in programming to how to use computers, how to deal with data, how to analyze it, and kind of use the GIS methodologies and techniques to deal with those kind of questions. And while doing that, so we have been experimenting with quite a bit of different technologies and techniques, and we have tried to make the learning for the students easier. And that is something that I will share you a little bit of our experiences, that what we have had in those. And indeed, we have been doing this since 2015, so quite many years already. And based on those two courses, so there's now a book coming, slowly but steady. So we hopefully get during this year this Python for geographic data analysis book finished, but let's see how it goes. And then also kind of the focus on this talk, thinking about the sustainability issues, is this new course that I have now just started. So we have first iteration done. So in this January, we had this course at Aalto University called Spatial Data Science for Sustainable Development, where we try to look at both of those angles, so spatial data science and sustainable development. And I will kind of share you a bit of my experiences and thoughts after the first iteration and share how challenging it is. Basically, it's quite tricky thing to develop a course that kind of has both of those angles under the same hood. Good, but let's start with the education part. So indeed, the first part is how to grow next generation of scientists with open technologies and empathy. And what we mean here by next generation. So basically, our perspective, of course, is kind of we are computational geographers, and we are dealing with data. So this is kind of more kind of aligned to doing things with data and computers. But what we mean by this is that we don't expect that everyone would be a programming guru or a data scientist. But what we mean is that people would be okay with computers. They can handle with data, and they know how to manage it. It can be big data or small data, both of them are needed. And then we mean that people would be able to analyze the data in a meaningful manner, and that people would know how to use, for example, version control, how to collaborate with other people. And these are very kind of important skills that are not kind of at the core in the university teaching, but they should come as part of the courses. And then while doing this, so we have always been kind of embracing openness and reproducibility. And well, we have in the audience people who have been writing about these things also a lot, and I fully agree. I'm kind of very pro open science, open data, and open source software myself, and being kind of an active member of communities that deal with these things. But indeed, it's also important to kind of keep in mind that there is also other needs, and not everything should be data science. And now there has been very good articles coming lately from Delmel, Franklin, and for example, Content Patty, that kind of call for impactful science and socially impactful kind of geography and geographical analysis. But anyway, even though everyone would not be a data scientist, it's still important to be able to communicate and work together with people who are good with data. So these kind of ideas have been at the core of our thinking when we have been developing the courses for geographers and geologists, and well, basically everyone who is doing something with geographical data. And then the empathy part. So what on earth I mean about that? So as any one of you who have ever started learning to program, I'm pretty sure that you can relate to this, that it is hard. And anyone who has been teaching programming probably also relate that that is also very hard. And the thing is that what I have been kind of witnessing and myself is that kind of when we are learning these new things that are can be quite difficult. So emotions are there all the time, and there are a few memes on the right side that basically can or show how we can feel whenever we are doing programming. So at one point we can feel like gods when we manage to do and succeed in finishing some piece of program or getting something to work. And then there are situations where we have no idea what we are doing. And at some point, even it can feel like success when you actually get a new error. So you don't even get the things working, but you at least kind of were able to get from one point to somewhere else. And I think these kind of things like emotions, they are not very much discussed. And I think they still are like inherently part whatever we are doing. And in the kind of courses and when we are teaching these things, we kind of witness these things all the time. So basically thinking of programming, so like coming to a more serious side, so there is some research that actually shows quite a worrying side of what it is to be a student nowadays. So basically this is a kind of study covering 26 countries and 234 institutions from various fields. And based on this research, they found out that graduate students are more than 6 times as likely to experience depression and anxiety. And I think that is quite a worrying thing. And they also kind of found out in this research that, of course, they wanted to know what helps with these kind of mental health issues, is to have strong, supportive and positive mentoring relationships with the staff. And those kind of correlate significantly with less anxiety and depression. And of course, we don't have any magic bullet to kind of solve these kind of anxiety issues and so on. But what we have tried to do is to try to ease out and make the courses that we have developed dealing with programming that can be quite challenging. So to make those as easy as possible, so that there would be more on the kind of positive feelings than the negative ones. And one of the typical challenges, or what are kind of the typical challenges that the students face when kind of learning programming? So of course, when we started doing these things or started teaching programming for the geographers, so there was this kind of barrier, this kind of feeling that this is too difficult, so I don't even want to get started. Because they are computers and they are scary and whatnot. And then there has been this barrier that relates to that I would like to jump in, but whenever I was about to start, I got stuck because I couldn't install the software. And this has been, especially 5-6 years ago, this was very much the case. And then there are these emotions that basically when you are doing some exercises, you get this kind of, you get stuck with the pieces of code that you're writing. Something doesn't work, you start to feel stupid, and then you start to question yourself that am I stupid? And these kind of emotions can come up when learning these things. And well, you can read the rest. There are many different kind of challenges that the students view. And then, of course, the teachers view. Well, this is too difficult. I don't even want to get started. That can also be kind of the view or the feeling that the teacher has. and you can have feelings that something doesn't work and you are stupid and you should know the answer to something, you cannot find it. These kind of things are quite typical when doing things. But in addition to that, there are, of course, these kind of pressures that come from actually the teaching work. So basically you need to provide grades, provide feedback, probably, or in some cases to many students, hundreds even. And at the same time, you should prepare the lesson for the next day, and so on. And then there are kind of always, at least what we have been finding quite challenging, is to keep different students with different levels of skills motivated. So some of them have 0 hours of experience in these things, and some of them have been working in a software engineering company for 10 years. So of course they are quite a different level in their skills. And then of course, like what comes to teaching, so of course we need to keep care about everyone and ensure that everyone is doing right. They should reach their learning objectives, they should graduate on time, and generally they should get a good starting point for the future. And at the same time, we should do research and be a good partner at home and be more fun and so on. So anyway, it can be quite tricky, kind of trying to keep these things together and get kind of advanced things. So basically now I have kind of few things that I want to share. Basically, how we have been approaching these challenges and how to have more of those happy feelings than the other ones. And these are the experiences that we have gotten from the GeoPython or the GIS and now the Spatial Data Science for Sustainable Development courses. And basically, what we decided already quite early on was that we decided with Dave that we will leave Moodle. So that was, I guess, in most of the universities, Moodle is the place where most of the teaching happens. But we kind of decided otherwise, and we wanted to kind of try out different open source technologies that makes the teaching of programming specific things much easier than having to be stuck with the Moodle environment. And the kind of idea and kind of the goal has always been to lower the cognitive load of students so that they would have less anxiety, as well as, of course, lower the burden of teaching, so less stress for us. And then, of course, we have kind of tried to choose the technologies that we use so that the students would also have those kind of skills that are needed in current working life when they are going outside to the university. So if you are doing data science, so there are specific kind of tools and skills that you need. So what we have tried to kind of engage them with is to kind of use this modern data science working environment, use like GitHub and know how to use version control, how to manage projects and how to collaborate with others kind of when doing programming. And here is it's a bit of a mess, but here we have basically the stack that what we are using when kind of developing and when we are running the courses that we have done. So as you can see, there are quite a bit of components. So on the left side, we have basically the different components of the courses. So we have a dedicated course site, then we do programming, we have tutorials, we have lectures, we have exercises. We need to assess those exercises. We need to give feedback for students and get feedback from students to ourselves. And then there is kind of question and answer going on all the time. And well, I won't go into details what technologies we have used, but you can read them from the right side. So there's quite a bunch of different things that we have decided to use, and what we are using now. We have been trying out a bit different things during the years. But yeah, the overall goal has been to make the hard easier in a sense. So if you have kind of a difficult topic such as learning to program, so how to do that as easy as possible. So I think the first thing that was quite obvious to us was indeed to have a dedicated website, and that helps a lot because you have much better accessibility to information. So the user experience of the student, so to say, is much better. So there's a kind of easy browsing, good search functionality, for example, on the course websites. There are no hidden documents. That's definitely something that kind of annoys me all the time on the Moodle sites, that you have different PDF files and so on that you need to click and try to find the information, and it's just a mess. So what we kind of try to do is that we embed everything. We embed video, slides, codes, everything to the same site, so that it is as easy as possible to kind of navigate. And of course, kind of from the pedagogical side, so constructive alignment is very important. So we try to be as clear as possible with the learning goals and exercises, and of course the assessment, and they always all should be well aligned. And that's kind of very, very important that we have found to work quite well. And now what is kind of new in the sustainability course, so in the GeoPython and AutoGIS courses, we have basically kind of written long tutorials, and they work quite okay. But then thinking about the qualitative side of introducing what is sustainability. So I won't be writing a book, basically try to explain what it is. So basically now what I have decided to use is to embed Google Slides, which are easy to use by also others, so I have visitors coming in to the course. So it works quite nicely, and you can even embed videos inside the slide. So it is kind of multi-level kind of stack of information that you can bundle into the same web page, which is quite nice. And then, of course, the one challenge that there was the kind of starting of doing the programming, so the installation issues and these kind of things. So what we started to use, I think already in 2016, was that we started to use cloud computing. So basically there is a single button that you press, and if you have an internet connection, you can basically kind of start doing the programming in the browser. And there is basically no need to waste time dealing with installation issues. And I think like there's many people doing nowadays this same thing, which is very great. And of course, we have kind of very nice initiatives such as Binder that basically has brought the kind of cloud computing for everyone, so you can just run it everywhere. Of course, the resources of using Binder, so you don't get much memory, which is the reason why we actually use this kind of CSC Finland supercomputing resources basically in our courses that provide like 16 gigabytes of memory for each student and permanent storage for the files. So with Binder, if you do something and you, for example, the battery runs out from your computer, so everything is lost. But in the CSC environment, they are kind of like computers in the sense that the files exist there, even though you would stop the instance in the meanwhile. But I think like we started with these kind of markdown files in the beginning, then we started using RST files, and then at some point we found started using Jupyter notebooks. And I think that, and well, many of others has also noticed the same, but Jupyter has really kind of revolutionized how we can provide teaching materials, how we can kind of do science communication and so on. So it has been great project to come around. And this is kind of a side note, but it's actually quite interesting looking at how the GI science community, how the number of kind of citations or links to GitHub, or kind of the kind of amount of sharing code with the articles has kind of increased and started to increase at the same time when the Jupyter and GitHub kind of partnered up in 2015. So this basically shows kind of how many times, for example, a link to GitHub has been put into an article. I will tell you a bit more about where the data comes from for that figure, but that was just a side note. And then, of course, the IDE, so the integrated development environment. So where do you actually do the programming? So there are IDEs that, well, everyone has their favorite. What again here has kind of made a big difference is to use browser-based, like Jupyter Lab. Jupyter Notebook was the first one, but it is really great to be able to actually document your code and kind of execute your code in the same document, and that has made definitely kind of writing the materials very easy for the courses. And also, well, we are writing the book. I know Dani and others are also writing their book using the same approach. So it's magic, I must say. And then collaboration, easy management of work is something that we have tried to teach for the students. So being able to use the version control, that is something that everyone should learn. Of course, nowadays with the kind of cloud computing and Google Docs and kind of online, Microsoft online kind of things, the version control comes quite naturally. People maybe doesn't even know that those exist. But anyway, kind of being able to have skills to kind of use version control and even know what it is, that's very, very important. What we have been using to kind of manage the student works and also kind of help ourselves in managing the work is to use GitHub Classroom, which is quite nice, a tool that basically automates kind of distributing the exercises, materials, and data. So you only need to have, the students need to have GitHub account. We are doing some tricks in the background, but in the end, they will just have a simple link on the website, such as this. And what it will do is that it will create them a kind of personal private repository that they can start using for doing their exercises and doing whatever they want. They can collaborate with their friends as you would do normally in GitHub. And at the same time, us teachers, we have kind of access to those repositories, so we can do grading and these kind of things. So that has helped quite a bit of distributing the work quite easily and managing that. And then, of course, communication. I think that's the most important part. It should be easy. It should be as easy as possible. There should be a dedicated kind of safe space where you can kind of chat with the students. What we are using is basically Slack, and we have like dedicated channels for each week so that they can ask questions, they can ask help, and the other students can help as well if there are questions, and we are kind of around. And naturally, kind of fun is definitely allowed. So what I stole from the guys at UCL CASA was that they had on their courses music recommendations. So that was a brilliant idea. I immediately kind of took that. It really helps breaking the ice, so that what I basically did was that every week I recommended some music for while doing the programming assignments. Listen to this song or that one, and I asked them to recommend something for me. So these kind of nice things can be done. And yeah, of course, nothing can replace the practical session. But now during these times that those are not possible, but typically there would be kind of like practical sessions where there are assistants helping out with the exercises, and the students can kind of form small groups with each other so that they can kind of help each other out when they get stuck and so on. So kind of building this kind of community and kind of social life inside the course is quite important and helps out, especially those ones who struggle with the programming kind of things. And then, of course, what we do to kind of show the empathy to teachers helping out us. So what we have tried to do is to kind of try to automate this as much as possible. So try to at least semi-automate the assessment and try to manage the student work as kind of fluently as possible. And what we do here is that we basically, whenever we are creating the exercises, we are kind of using NB Creator, which is a great tool, quite a lot used by many people, which you can use to basically create in notebooks, kind of create exercises that are can be automatically created. Creating good exercises that can be automatically kind of checked by these kind of tests that you write with the NB Creator. That's the most tricky part, actually. And it is a challenge, and it is a bit of trade-off between flexibility, like how the students can kind of be creative with their programming, and then the other side of actually managing and making things easier for the teacher. But anyway, this is kind of the pipeline. So we start by creating the exercises and creating the tests, and then we kind of create the release version of those exercises where the answers to those kind of exercises are not available, but they are of course available for us teachers. Then we distribute the exercises with the GitHub Classroom, as I mentioned. Then the student does the programming work using the cloud computing or their own computers. They can use them, of course, as well. Then they push the exercises to GitHub. Then they are kind of, we have created this, or Dave actually have created this creator bot, which is basically built on top of GitHub Actions. I've written this kind of creator tools tool that kind of fetches the kind of clones the repositories and does different kind of magic so that we can automatically use the NB Creator that then actually does the automatic creating of those exercises. And then what the creator bot does is that it actually generates the feedback automatically and pushes that to their GitHub repository. Naturally, everything cannot be kind of automated. So there is always someone typically who will also go manually at least part of the code so that we can give feedback for example, from the programming style that they are using. If there are some kind of things, we try to, of course, promote these kind of good practices in programming and so on. But anyway, this is kind of what we are using quite a bit, especially on GeoPython and the automating GIS processes. Everything works more or less like this. On the sustainability course, this is not yet working, so I don't yet have like automated tests because they take time. And of course, as you can hear from my talk, so this is laborious, but once it's done, then it's quite easy. Then you can start managing large groups of students quite efficiently with this. So some experiences. So, well, the feedback from students, they like it. So they like the kind of learning environment that we have created. So we receive fairly good feedback regularly. It is easy to manage everything from the teacher's perspective once everything is set up. Now, when I did this for the first time to this sustainability course that I had, there is quite a bit of things that needs to be done by me to get everything working, and it's a bit of hassle. So there is a kind of bit of a bottleneck in there when doing it for the first time. But once it's done for the first time, then it's fairly easy to maintain it for the following years. It's very easy to collaborate between teachers. That's also one of the reasons why we originally started doing this, so that Dave and me, because we did the course together and we thought it together, and then Vuokko came along as well. So we all collaborate using GitHub and this kind of typical practices that you use whenever developing software. But what we have learned is that also the assistants, they are very quick to actually catch up. So after a bit of guidance, they kind of can manage these things as well. It's easy to update contents. It's easy to keep kind of history of the courses. So we basically have since 2017. If you took the course, for example, in 2017, and there was some part of it that's not anymore available, for example, in the current release, so you can always go back and check it from there. Of course, the world might have moved on while waiting, so the code doesn't necessarily work, but it's still there. And the resilience is fairly good. So others have been able to continue the work. So indeed, I basically came to UK in 2019 and spent there a couple of years, and now I came to Aalto, but still people have been able at the University of Helsinki, they have kind of been able to continue the course and continue the work. Of course, I help here and there, kind of setting up things, but still it's fairly kind of resilient in that sense. And of course, what is nice about kind of doing open education is that, well, you kind of can have feelings of doing at least something right by helping others. And it has been quite surprising how popular, for example, this automating GIS course has become. So in the past year, I think only North Korea was the only country that there wasn't visitor coming to the site, and there is almost 200,000 visitors annually. So it's of course quite nice thing to witness. But then, of course, there are the downsides as well. So as I mentioned, setting up the environment for the first time it's a bit laborious. It does require maybe above average technical skills to manage everything. So you need to kind of be into computers a little bit, but still, well, I'm a geographer and Dave is a geologist and we did it. So I'm pretty sure that quite many can do it as well. And as I mentioned, making good exercises is hard, and making good exercises with automated tests is even harder. And what has been, these courses are intensive, so there is a lot of work for students, but they do learn a lot, and they do appreciate the things that they've learned. So that's maybe well, kind of between pro and con in there. But then coming to the spatial data science programming plus the things that matter. So this is a nice tweet and kind of meme that I spotted from Twitter that kind of shows what it can be at some points when doing coding and focusing and being doing things that are cool and so on. And in the end, it's other things that really matter. So what I wanted to do with this new course was to kind of try to mix those two. So I ended up, it was the first week that I came to work and I needed to say the name for my new course, and this is what I ended up doing. I'm not sure if I would do it again, but anyway, so Spatial Data Science for Sustainable Development. So the aim of this course is to kind of not only provide the programming skills and data analysis skills, but also kind of dive a bit deeper to the kind of topics from the qualitative side. So going to the kind of sustainability issues and teach about those. So on the left side, those are basically the aims or the objectives directly taken from the course. So what are the aims in here? And the target audience, so for whom this is targeted specifically, thinking of my new job at Aalto. So it is targeted for the MSc and PhD students doing geoinformatics master's program, and also other disciplines at the Department of Built Environment. Maybe a good thing to know is that we are at the School of Engineering, so there are engineering students mostly, or well, mostly everyone is an engineering student. So they have strong mathematical and technological background, but not necessary. They don't have much knowledge about these kind of topics that we get when we are doing geography or social science programs, for example. But naturally, it is available for anyone who is interested in these topics, and it's openly available. But yeah, there's a warning. This is the first iteration, and of course, whenever you are developing things, you have great ideas, and then you do what you have time to do. And that's kind of especially the case for the first iteration in these. So experience. If teaching programming is hard, teaching spatial data science plus sustainability science that have kind of quantitative and qualitative sides, it is very hard. And I still think that we should do that more. But as said, it is hard, and I will tell you a bit more. When I started doing this, of course, I kind of wanted to check out what is kind of out there. So what is kind of spatial analysis, GIS courses, or these kind of things that would actually deal with sustainability. And I was quite surprised at how few kind of courses I was actually able to find. There might be that these kind of things are part of other courses by themselves, but at least having the keyword in the course description, like sustainable development or sustainability, there isn't much. There are basically in Columbia University, there are few courses. At the University of California, Dornsife, there is kind of this minor program, GIS and sustainability science, but it is basically bundled from many courses. So it's not really like having a full focus on these things. And then there was like one summer school, and then there is this course that I now developed. So I'm not sure what's going on. Maybe I just haven't found the right places to look. But anyway, I haven't found too much of the educational materials for these things, and nothing is open. Well, except now the course that I did. But there are, of course, other initiatives such as this United Nations OpenGIS initiative. They have some educational materials, for example, using QGIS and doing these kind of things. There is a nice, very nice kind of new, I think, well, maybe it's a book, like Mapping for a Sustainable World, done by UN and basically ICA, which is quite nice. Kind of introduction to sustainability and how kind of different kind of visualization techniques and what is geospatial data and these kind of things. So it's very nice. And then some resources that I found otherwise from here. But then kind of what is sustainability? And of course, this is the kind of first question that we are kind of looking during the course. And well, I won't go into details. I'm pretty sure many of you have your own idea already what sustainability is, but typically it is kind of divided into these three pillars: social, environment, and economical pillar. But what I did was that I asked from the students actually in the exercise 1 that what does sustainability mean to you? And actually, if there would be a poll, I would love to do this now with you as well. But anyway, what I kind of, when reading through the kind of answers from the students, it was quite evident that kind of it is not too clear how broad the kind of sustainability field is, or the concept is. So typically there is lots of kind of economical perspectives coming in, like reducing consumption and doing these kind of things. Then there are the environmental perspectives, like kind of what I do is that I have specific diet that it tries to be more sustainable. I don't use car and these kind of things, and things related to kind of nature. But what was quite evident was that the social side, so the social sustainability, there was quite a few. And well, I'm not sure if I'm surprised, but that was what came out. So kind of understanding things like equity, fairness, justice, rights, these kind of things didn't came up. Well, there were few, but not many kind of answers when asked about what does sustainability mean to you. And yeah, now then there are these kind of key, like what the students should learn. That's of course a good question, and what the students should learn in terms of sustainability. So there is this kind of 8 key competencies from the listed by UNESCO, basically. So they have listed these kind of competencies that the students should know and learn when kind of dealing with sustainability. So system thinking is one, anticipatory competency, normative competency, and so on. I now run this a bit faster as the time is running. But anyway, what we can see when reading through some of these points raised in here is that they are very complex and they combine the social side of everything. They combine the values, perceptions, and the actions of people, and everything kind of bundles together. And of course, doing this is very challenging. Definitely not something that in one course could handle. And in the end, the idea is to kind of merge all of these together so that they could be applied to different problem-solving frameworks and so on to kind of tackle with these questions. And when I read these things, and I'm pretty sure if you read them yourself, it blows, at least it blowed my mind. It feels very, very, very challenging, and that is basically kind of my experience. That doing these things and thinking about things in the education, let alone in science, I think these are actually very good guiding points for our scientific work as well. Thinking that we could actually not just pick those our most loved ones sustainable development goals and attach them to our research, but we could actually look at, for example, something like these and think about that, okay, could we maybe steer our research a bit in that way, that we could actually provide some input regarding these kind of challenges and these kind of things that, for example, the smart people have thought to be crucial in the student's mind. What I did was that I basically used the Sustainable Development Goals as a starting point for doing the course. And as I said, this is very nice because there is something for everyone basically when looking at these different Sustainable Development Goals. And it's a blessing in a sense, and then it's a curse as well, because of course, how do you frame the contents? How do you pick the ones that you teach is very challenging and very complicated, especially when starting to think the kind of combining the qualitative and quantitative sides. But what is very obvious and is that systems thinking is required. And this is what, I'm not sure how many of you are geographers, but this is what we were born to do. So I think as geographers, we are quite strong with this kind of thinking of systems, social systems combined with environmental systems and so on. So it's much more natural for us to think about these things than, for example, maybe some kind of engineers that I now deal a lot with. So that's no idea. But yeah, how to combine qualitative and quantitative side. So it's $1 million question. It's hard, but still, like doing proper teaching with these things is there should be combination of both of these things. What I ended up doing was indeed that I basically put most of the students work in pairs. I didn't kind of force them, but many did, and each lesson basically was divided into this kind of sustainability oriented lecture material, and then there was the programming tutorial side, doing the kind of programming things and spatial data science. And then the exercises kind of were there were tutorials, and then there were the exercises where the idea was to kind of think about these things and then kind of do something in practice with data and kind of reflect between those two. And that was the kind of thing that I ended up doing. And these are the contents. I won't go them into detail, but basically these are very biased, of course, based on my background. But what we are doing here is to do some spatial accessibility modeling while discussing about human well-being and justice and health accessibility. So we do some two-step flow engagement assessment analysis there. Then we move to sustainable cities, sustainable mobility kind of concepts from the sustainability themes, and do kind of trajectory data mining on the Python world. Spatial interaction models is definitely coming up, but now I didn't kind of have time to do that. Let's see how it goes. And then kind of decent work in economic growth. There is actually, I borrowed some kind of material from Danny. I'm very grateful for that. But basically what we are doing is to do some spatial regression in there. And then we have agent-based modeling, thinking of the current COVID situation. Then some spatial prioritization related to biodiversity crisis and kind of do, well, yeah, spatial prioritization analysis related to nature conservation. So these were kind of how I built up things, and it worked quite okay. So students liked it. I think the feedback was kind of supportive. It is very intensive, especially now the first time, because having no experience of doing this before, so it's very tricky to develop anything. But now, of course, with this experience, things can be improved. But there was a lot of work for the students and a lot of work for me as well. So, of course, the question is that how to make this more sustainable. And being a teacher and dealing with this hard topic, so the feelings of incompetence were very kind of familiar. It is hard, and what is very much needed is to collaborate, do things together with people who have expertise on these different areas, and then do something together. And I think thinking that we have what is basically needed, and we know how to do things. We have kind of open source communities who are building these things. We have developed a lot work, open educational materials, and we are using more or less similar kind of approaches to do those things. So there's a question that could there be some kind of network or community that could maybe together think about these things and push them forward, because there is not much, as I mentioned, any education about these things. But I think this is so important topic that there should be more about these things. But then very quick kind of glimpse to the science side. So of course, after doing this course, I got very interested in knowing that, okay, if there is not much education about sustainability topics coming from the kind of GIS community, what about research? So I got interested in kind of to understand how we engage with the sustainability topics in our scientific work. And what I did, these are still preliminary, results. So anything haven't been peer reviewed yet. So take these with a grain of salt and point out anything fishy that you see. But what I did was that I wanted to understand what has been published in the top 20 GI science journals between 2015 and 2020. And 2015 was the year when the Sustainable Development Goals were basically launched. So that's the reason for that time span. And then I was interested to understand what has been published in the top 50 sustainability journals, thinking that the sustainability is so broad, so it makes sense to have more journals from that side. And the questions that I was interested in was to understand how much sustainability or how many sustainability related articles are published in GI science journals, and which kind of sustainability perspectives do they focus on. And then I was interested in to understand the engagement between these two communities. So how often do we cite articles published in sustainability journals, and how often they cite the work published in GI science articles? So these were the kind of questions that I was interested in. The data that I used for this comes from this dimensions.ai platform that basically provides open data, and they have an API as well to 170 million articles from 86,000 journals. So this is pretty nice source of information. And what you can get from there is publication details. You can get the references to that specific article, and then you can get the citations to that specific article. So everything I basically needed for these specific questions in here. And then, of course, the hot potato, what are the top 20 and top 50 sustainability journals? So, of course, I didn't want to start thinking about these things myself, and there is not a right answer to this question. But basically, I based my searches to these two articles. So this is kind of article published in 2015, so it's already a bit old, and there was actually one journal that doesn't exist anymore. So the top 20 is actually top 19 in the analysis that I did. And then this is a bit newer article from 2020 that basically ranks the top 50 sustainability journals in sustainability. So these are the top 20 GI science journals. I think from kind of doing spatial analysis, they are more or less at least many familiar journals that I find. There are a couple of journals, so Computers, Environment and Urban Systems and Environment and Planning B, that are actually part of both the GI Science top 20 and the top 50 sustainability. So that's maybe a good thing to notice. And yes, there are some borderline journals in this article. So there are some journals such as this International Journal of Applied Earth Observation and Geoinformation that maybe is more inclined towards kind of remote sensing and this photogrammetry and remote sensing. So there's a bit of question that should they be here, but anyway, they are. And then the top 50 sustainability journals. I won't go through them, but well, here they are. So there is Nature Climate Change is the top one based on the 2018 ranking in here. Good. Maybe a good thing to note is that this basically kind of contains the journals are based on the Web of Science database in this article, and there is basically the two categories that were selected when doing this or selecting these journals, so environmental studies and green and sustainability science and technology. So the first thing that I looked was that I wanted to understand that how often specific keywords related to sustainability has been mentioned in the title. And this is now basically looking at all the articles published and available from this dimensions.ai. So there are, well, millions of articles. And what we can see is that basically there has been in the last 20 years, 15 times increase of the kind of times when these words mentioned in here, so sustainability, sustainable development, blah, 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 you can read them from there, are mentioned in the title and abstract. So there is definitely kind of interest towards these topics, and it is growing. Then coming to the top 20 GI science journals. So what I kind of did here was that I made these kind of key term baskets. So I have this kind of generic sustainability that has these terms basically that I was using also with the kind of overall articles. Then we have like social sustainability keywords that relate to, for example, if there is equity, justice, equality, vulnerability, well-being, these kind of things mentioned in the title or abstract. And then there's the environmental sustainability, where there is kind of biodiversity loss, conservation, protected area, land use change, these kind of things. And then there's the conservation science, which is, well, maybe a specific interest of ours, how those are mentioned in here. And this is basically what we got. So it is kind of, if we look, this is the 3%, which is kind of the, when looking at all the publications published in 2020, that's the proportion of articles that's related to sustainability. So we can compare that line in terms of these different journals. And here is the percentage of sustainability related publications in each of these GI science journals in here. And what we can see is that kind of having generic mention about sustainable development, it is quite typical to have that thing in the abstract. Whereas when going to more detailed, like some social sustainability angle, it is much less kind of frequent mentioned in the GI science journals, and the conservation science is even less. But indeed, this is a bit problematic kind of approach, because finding good keywords is challenging, and relying only on abstract is probably not not the best. And some people might want to avoid these kind of buzzwords, such as sustainability or sustainable. So there is a kind of these challenges that comes with looking the data like this. But this is maybe a more revealing. So what we have here is a network of kind of what we are referencing. So from the blue top 20 GI science journals to the red actually it's top 50 sustainability journals, and the links to those different journals in here. And the node size basically shows the number of received or sent citations, and the edge width is the number of citations between journals. And basically what we see here is that T journals haven't got any citations from GI science kind of community, or this top 20 journals. 16 journals have received citations from 1 to 4 GI science journals. So there is a large group of sustainability, top 50 sustainability journals that kind of receive some attention from us. And then there are basically 4 GI science journals that have cited very large number of sustainability journals. So AAG, EJGI, and then, well, Environment and Planning B, and Computers, Environment and Urban Systems, that are more kind of applied journals, so kind of makes sense. And most citations goes from, well, between 2 MDPI journals, so International Journal of Geoinformation and the Sustainability, which are both MDPI journals. So it seems that we do acknowledge and we do cite articles published in sustainability journals, but half of the top 50 sustainability journals are not getting too much attention. And the question is that, well, should they? And more than half of all the citations that we give is actually received by 7 sustainability journals. So it seems that our attention is quite narrow in scope. So we tend to give the citations to specific journals. What does that mean? I think it's, well, up for discussion. And then what about other way around? So do the sustainability scientists cite us? So there is basically 5 journals who haven't cited any of our kind of top 20 journals. 25% of all the citations that GIScience journals get comes from MDPI sustainability. So it is very biased to this one single journal that actually kind of cites to different journals in the top 20 journals. There are 13 sustainability journals that have cited very little, so to only 2 different journals in the GIScience, these top 20. There are 14 journals that cite to basically half of the top 20 journals. So these are the most engaged ones with our journals. And the most citations goes again between these 2 MDBI journals. So from the Sustainability to International Journal of Geoinformation, and the AHG is kind of having the most broad attention from different journals. So it receives from 38 different journals citations. So the thing is that 5 of the 20 or 19 GIScience journals receive 60% of all the citations from the sustainability kind of community. So it kind of seems a bit that our work is maybe not as visible as it could be for the sustainability journals and the scientists. And I guess the question is why, and could we somehow improve this, or is this okay, or what does this mean? I guess these are the questions that that kind of come up with this thing. So what I believe as a kind of final thoughts is that we maybe should discuss about these things a bit. We should kind of think what is our role in these kind of sustainability topics. And as basically most of the data is spatially referenced and everything happens somewhere. So, and basically the sustainable development goals are inherently spatial by nature. So it's a bit surprising how little there is engagement between our community and the sustainability community. But of course, the sustainability, it is very challenging both from education and scientific perspective. So maybe this is part of the reason, or maybe it's just that there are just different journals that kind of where we do that kind of work. Or maybe there's just something wrong with the analysis or the assumptions that I have done. But what I have witnessed in our university at Aalto is that there is definitely need for more education on sustainability, both for the students and for the staff, so that we would also kind of understand the bigger picture of these things, and not only to pick the kind of best suitable themes or sustainable development goals that suits to our needs, so that we get this kind of impact to our papers. Of course, I don't kind of blame anyone, but that at least something that I have done, and I would assume maybe some others have done as well. But indeed, I think, as many other scientists have said as well, that there is kind of need to have maybe new thinking and embracing also the theories and embracing the quantitative and the qualitative side and thinking of those together. So doing some mixed methods and using those when doing science. And that's because these kind of global challenges that relate to sustainability, they are so complex and they kind of have the social, environmental, and economical side in them. So it kind of requires a bit of maybe new approaches to tackle these things. that's it. Sorry, I went over time, but quick mention from Rafa is that we have a special issue in Environment and Planning B coming. The deadline is on September, and yeah, if you are into kind of spatial and transport network analysis, so please consider this. I think it will be great. There is more info from that link that you can read about. And now, thank you.
Thank you, Henrikki. That was a brilliant presentation. You touched so many topics, and we already have quite a few questions here and some raised hand. So, no, that is applause. So, okay, true. I'm still not very used with this virtual conferences. I think I will never get used to this. Anyway, people are applauding at your presentation, which was very, very interesting. So I will go through the questions that are already in the chat. So the first one is from Danny, who asked if CSC is only for Finnish universities, or that can be accessed also from those in the UK?
Yeah, that's, I believe it's basically CSC is such an institute that it's owned by the Finnish Ministry of Education or something like that. I'm not totally sure, but it's basically, yeah, it's for the Finnish, unfortunately, it's for the Finnish kind of students only and researchers. I know in UK, the situation is a bit different when I was there. So there are many these kind of different kind of providers that do collaboration, but it's maybe more kind of university-led kind of infrastructures that are there. Of course, you know better, but that's what I maybe learned when being there. There should be something that everyone could use, definitely. Maybe we could send an email to Google or something.
If I may jump in just really quickly, do you know a little bit of what's the, I guess, since we're talking about sustainability, what's the funding model for these? Because the cloud is not cheap to run. And I suppose this is somebody needs to be paying these. Is this fully provided by the ministry, or is there any other model that this runs on?
You mean the Finnish system? It's basically,
CSC,
I think,
yeah,
it comes, I believe most of the funds come from the taxes, basically. I'm not totally sure about the funding mechanism, but I would assume that that's at least the primary source of funding.
Okay, so then Martin asked, how do you convince traditional GIS user, so ArcMap, QGIS, to put effort into learning Python?
ArcGIS, well, I don't know if I'm the best marketing person for for these things, but the reasons why I kind of swapped from ArcGIS is basically the kind of liberty and not being stuck with kind of a single vendor, and of course we have the licenses at the universities quite often, but I think it is just nice that you are not tied to a single system. And of course, kind of ArcGIS have some limitations, of course, very good things as well. I'm not saying that, but I'm more into doing things together and being open than kind of doing the other way around.
If I may add on top of that, I quite often from my field, which is most urban morphology, I hear a question: why should I give an effort into learning these things? I can do all the stuff I do in QGIS. Why should I spend a lot of time learning these things? And it's hard to convince these people that this is the proper way of doing that reproducibility makes sense, and that, yeah.
Yeah.
Yeah, then we have a question from John Dogby. he asks, can we, in Africa specifically, he's wondering about Ghana, virtually participate in the course?
Well, there are these questions quite often coming up from different parts of the world, and yes, basically you can. Well, in the lectures, I have basically kept them kind of close to my students as well, and I believe now at the GeoPython and automating GIS courses, it's the same situation. But what quite many people do is that we have kind of list of people who are kind of interested in following along. So we kind of send them information when the course starts, and then they basically kind of keep the pace that we do these things. Definitely, like, yeah, it's a bit of kind of trade-off between our resources and so on. Of course, it would be kind of, I would love to teach like everyone interested, but then again, like providing feedback, for example, so it takes resources because everything cannot be automated. So there are kind of these reasons for not letting everyone in there. If GitHub would, what we would hope is that they would kind of provide this very easy automatic assessment that you would in GitHub basically have a button that you could like run a piece of or basically push a piece of code to GitHub, and then the GitHub would automatically do some tests based on specific cells that you would immediately get feedback back to the repository. So that would of course make it much more kind of interactive, and you could kind of get feedback. Of course, you don't get any written one, but that would help out quite a bit in automating more of these things.
Okay, so then there's a question from Francisco. He asks, what have been the main challenges you have experienced setting up a computational environment for students? For example, how do you cater for different operating systems?
Yeah, basically why we started using cloud computing, I think the first or second year we did these things, we actually put the students to install the softwares on their own computers. And of course, I know Dani is using Docker, and that helps a lot. But then using Docker from Windows is a bit of a hassle, and that can be a bit, because Windows is basically what everyone uses in Finland. But kind of getting rid of the installation issues was kind of the first and primary motivation for us to kind of starting to use the CSC services and then the binder and these kind of things, because it is basically always running under the same, or more or less the same Linux server in there, and there is no hassle at all. We do encourage people to use Conda, for example, and basically building Conda environments if they are using their own computers, and that's of course makes life very easy, or much easier as well. But yeah.
Okay, so then we have another question from Dani, asking what would you say are the benefits of teaching in the same course substantive domains, for example, sustainability and programming data science? And I don't know whether Dani wants also add anything.
Yeah, no, it was, I was curious because I mean, I think, as you said, these are some massive challenges on their own. And I was wondering whether there's any synergy and you kind of get more than teaching the two separate, or you find that you can get less actually than if you had two courses on one of each, or I guess what's the motivation behind blending the two into a single course? Because the question came from your slide where you said that there wasn't any course on sustainability and data science, and kind of my first reaction was that's probably because that comes at the program level. So you will have a master's in sustainability, and there would be a course in data science, or a course in data literacy, or a course in GIS, and it's delivered in different courses. I was wondering what the benefits, now that you've done it, what benefits have you seen of doing both combined in the same course?
Yeah, I think actually at Aalto as well. So it is basically the sustainability is at the core of the university strategy. So in every course that we give at Aalto, we need to think about what kind of sustainability development goals they kind of attached to, which is quite interesting, especially it's a technical university. So I'm not sure if everyone is happy with that kind of requirement. But I think one of the reasons why kind of I started thinking and putting these together is the fact that people would actually, because many of the things that people, especially people who are not like very kind of, they are not GI scientists, they are more into applied kind of world. They can do a little bit of programming and so on, but like doing something different than what is kind of written in some web page and so on can kind of get very tricky at any point. So one of the things why I wanted to do this is to actually kind of give examples of how these kind of data science approaches can be used exactly to this kind of sustainability issue. I'm not sure how well I managed to do it now, but definitely the plan is to kind of try to integrate them more together. And then I guess one of the things I'm kind of intrigued by the thing that we should kind of think about approaches where these more kind of using mixed methods and putting these as there was these 8 components of the kind of UN recommendation what should be thought for students. So I think it is also interesting for me to maybe think about how they go along. But yeah, it's a fair point that you said that would it just be better to have these 2 things separately or not? But I think giving examples, and I think also like maybe one of the reasons why the GI science community is not so much cited from sustainability is that if there are no kind of clear connections and easy to kind of approach examples for the people who are not specifically GI scientists, so they just don't find relevant things that could, like relevant methods that would very much be suitable for some of their problems because they don't know the right words to find them and these kind of things. So yeah, some of the thoughts.
Yeah, and then probably very much linked with this, Caitlin comments is that this is a very interesting approach. And she wonders, how do you find balancing tricky theoretical concepts, for example, rights and justice with technical skills? And if you feel that students succeeded in integrating the two in what they produce during the course. So it's very much linked with what you were discussing before.
Yeah, it is a challenge, and I think like let's see where this course evolves. I think like as like thinking of these issues and kind of bringing different ideas from different kind of background, people from different backgrounds, having like some technical and some with more kind of social science background together. I guess that is anyway what is kind of needed, and then how to do that in this course is of course a bit limited, but there is a kind of mixture of backgrounds in our students as well a little bit. So kind of try to put together different skill sets is definitely something that is needed, but it is challenging. And I think, well, the kind of qualitative side that like basically they needed to make a written assignment for specific questions that I had. So it was possible for them more or less to kind of follow along the check the video of the lecture and read the materials from the slides, and they were able to kind of answer to them. And then as the programming part and the written assignment were linked together, so it allows them to kind of think about the angles, like what can spatial scientists do to help with these specific topics.
I mean, if I may say, as a student, from my experience as a student of a mixed course where I had theoretical sustainability topics and some more technical with ABM specifically, and well, in relation to that, I don't know if you're aware of the work of Giacomo Bravo, who actually had a course similar to this that mixed technical things with sustainability issues. Now he's in Sweden, I think, teaches, but it was for
interesting
in University of Torino. Yeah, I can.
Yeah, definitely sounds interesting.
Yeah, because it was a few years ago, so probably not very updated as a course, because I mean it was my master, so a few years ago, unfortunately. But anyway, as a student, I really enjoyed that, and you're completely right that making this link is not so automatic when you have two separated courses. So another question from Birka. So the question is whether in the review of the research done between 2015 and 2020, if you included mainly articles published in English or not?
Basically, in the kind of bibliometric analysis, so they were all the articles published in these specific journals that were chosen based on this kind of one review, or the kind of paper that what I used to make the selection of journals. And there is no, actually the one that was basically not anymore available, or basically that was shut down in 2017, it was maybe German, but most of them were, yeah, indeed English journals.
So another question from Kari. Did you use criteria biodiversity, as it will produce different results than environment and conservation?
I had basically, I think biodiversity loss was one of the terms that I used. I'm not sure if I used biodiversity alone in there, but yeah, as I mentioned, kind of finding out the good keywords, it is a bit tricky, and you should basically have a bundle of people from different fields of study to think about these things to get them right, and still try to avoid of getting like something like I did a search for remote sensing to get an idea of what remote sensing guys are doing, and I get a lot of health related things, because of course remote sensing is also something related to medical equipment. So there are these kind of tricky things when it comes to these keywords.
Okay, Martin, again with the around the bibliometric research, is it somehow normalized by the number of published paper? Sustainability Journal publishes incredible number of articles every month. So.
Yeah. Basically, the numbers that they were normalized by the number of articles in that kind of published in that given journal. So they were basically percentage of articles published in that journal that were on the graphs.
Okay, so another question around remote sensing from Labib. So remote sensing is now getting a lot of attention in sustainability science. How do you think we differentiate or integrate remote sensing as spatial data science? Can we even consider both as subdomain of broad geographic information science? Also, in his experience, he found a lot of remote sensing papers that are used in Sustainability Journal. Did you explicitly extracted some remote sensing journal citations?
Basically, yeah, the journals that were selected were just taken from that one paper, and indeed the idea in there was that the journals would be such that the focus in the journal is more like spatial analysis, not the kind of Earth observation things and remote sensing. There is definitely like there is a different group of journals that are important in the remote sensing world, but yeah, I was mostly interested here in the kind of spatial analysis world. Of course, remote sensing has always been very, very important in terms of like observing what happens in terms of different phenomena related to sustainability and global change and climate change. So it has been very important always, and will be. So it's maybe a bit would get different results, but I haven't looked at that.
Okay, yeah, I think that was okay. Okay, so people now are really thanking you for your talk. I would actually close. I mean, I did have a few questions. I mean, I don't want to, but I know that you already received quite a lot, but I just want to say just one, just to highlight something that is so rare to hear. And I did really appreciate that you've been talking about empathy as well while discussing this. It's a really nice thought to have. And I was thinking, in your experience as a teacher, I mean, you've been teaching both before and during the pandemic. So do you think that there's something that you've learned by being forced, let's say, of doing everything online, and whether there's something positive, let's say, to get out of that?
Yeah, of course. For me specifically, the kind of change to kind of pandemic world wasn't actually that big of a deal, because we had always recorded our lessons and they have been available on YouTube and so on. But of course, it's a big difference in kind of not being able to be on the lecture hall, being able to communicate with students in there. What we have been trying to do is to somehow try to engage with students, but it's hard. I'm pretty sure you have experienced the same thing. There are lots of black screens on the monitor, and when you are using Zoom, you see yourself, probably maybe one other student in the corner. So I don't know how humane that is. So I'm at least very excited in getting back to fellow friends in the university.
Nothing to save though. Well, I mean, it's reasonable. I also kind of hate this 100% virtual sort of environment. So I do.
But definitely, I think what we are doing here, I very much hope that this will continue. Having kind of very like nice visitors from different parts of the world, it's definitely kind of easier now because people are used to it, and so on. I did like before maybe 2018. I have Geoff Boying. He was still then at the Northwestern University, but he visited on the AutoGIS course. But it was very different. It was kind of, I prepared everything like very, very well and did the recording before, and then did the editing of the video and so on. So it was a bit different than what things are now.
Okay, so thank you very much, Henrikki. That was a brilliant talk, and we also had, I think, a very nice discussion. And so I would leave it here. I mean, you have the link to go to now, and so with some of the lab, I think we will meet there in a few minutes. But again, thanks a lot, Henrikki. That was great. People are thanking you a lot. I mean, everyone seems to think that.
Yeah, thanks to you for organizing. I think like the seminar series is brilliant, so it's very nice to have this.
Yeah, it's going well. It's very interesting to have, and as you said, it's amazing that we can have people with, not having the problem to move physically to Liverpool. So that is probably the only good side of all this. Yeah, thanks again. And for everyone else, please watch out on the Twitter channel. We will announce future seminars there with all the information to register and so on. Okay, so thanks, Henrikki, and see you soon.
Yeah, thank you. See you.
Okay.
Bye.